Assalamu alaikum viewers, I am Dr. Arshad. In this video we will discuss the radical and exponential form of the nth root of a real number. First we define the nth root of a real number. Real number x is said to be the nth root of a real number a if x power n is equal to a, where n is a positive integer greater than 1. Symbolically, we write x is equal to a, and this is the notation which is called the radical. Here n is called the index and a is called the radicand. This is the form which is called the radical form, or we can write x is equal to a power 1 over n. This is called the exponential form because a is written in the form of exponential or in the form of a power. As already mentioned, this symbol, this is the radical sign a, this is the radicand or the base, and n here, this is the index of the radical. The square root of a real number is generally written as a square root is equal to a square root, that is without writing this 2 over here. Now we discuss some properties of radicals. Let a, b are any real numbers. A and b, they are any real numbers, and m, n are positive integers. B positive integers, both greater than 1. Then we have the first property, AB whole nth root, that is the nth root of the product of AB. It can be written as the product of the nth root of a and nth root of b, like nth root of a and nth root of b. Second property, this is the fraction of a and b, nth root of the fraction of a and b. This can be written as nth root of a divided by nth root of b. Third property, the nth root of mth root of a. This is equal to mnth root of a. Then we have the fourth property, which is nth root of a power m, which is equal to the power of the nth root of a, mth power of the nth root of a. Then the fifth property, nth root of a power n, which is equal to a. Now we'll solve some questions from exercise 2.3. We will write the exponential notation in the radical notation and radical notation in the exponential. The first one is given as negative 64 cube root, that is the cube root of negative 64. We know that it can be written as negative 64 power 1 over 3. This one, this is the radical notation, and this is the exponential notation. Second, 2 power 3 by 5. Here 1 over 5, that is the fifth root of 2 cube. Fifth root of 2 cube. Then third, negative 7 power 1 by 3, which is the exponential form. We'll write this in the radical form as negative 7 cube root. The fourth one, y power minus 2 by 3. This can be written as the cube root of y power minus 2. The cube root of y power minus 2. This 1 over 3, this is the cube root. This is the exponential form, and this is the radical form. Similarly, negative 7 power 1 over 3. This is the negative of the cube root of 7. Here 1 over 3 shows the cube root of 7. Now question 3, in which we have to simplify the given radical expressions. The first one is cube root of minus 125. Now we know that minus 125 can be written as negative 5 into negative 5 into negative 5 and the cube root. Because we know that negative 5 into negative 5 is 25, and then multiplied by negative 5 we get minus or negative 125. From here we can write negative 5 cube and the cube root, the third root. From here using the property that is the nth root of a power n is equal to a. Here this is our number, for example a, it's power 3, and we are taking the third root, so simply we have negative 5. Next we consider the second part, which is the fourth root of 32. Again we can write 32 as 16 into 2 and the fourth root. This can be written as fourth root of 16 into fourth root of 2 by using the property nth root of the product AB. This is nth root of A into nth root of B. Here, for example, this is our A and this is our B. From here we know that 16 can be written as 2 power 4, the fourth root, and the fourth root of 2. Again using the same property, 2 power 4 and the fourth root, we have 2, and from here we have fourth root of 2.